Okay, so I'm going to go and help you to trace this pseudocode that is shown here on the left-hand side. This is the example taken from page 6 on the summer task, and we're going to look at how to fill in a trace table, which has been filled in already, again on page 6 on the right-hand side. Let me start off by saying that the trace table will have the relevant variables and I at sum, v1, v2, whatever is output, that the pseudocode uses. And so the idea of a trace table is that we try to record what happens to the algorithm with particular values that are input and obtain output values. This will help us to understand what an algorithm is, what pseudocode does. The main point to make is that you don't need to look at the pseudocode and understand the whole thing from just looking at it. A trace should generally be looking at each individual line, being careful to look at what that line does and to record it on the trace table. The second thing to say about a trace table is that when we have a value, for example I here starting at 3, and then it changes, so let's say 4, we don't cross out the 3, we leave it there and write the new value underneath. So this tells us that on this particular row that I has a value of 4, the 3 has been forgotten, it's not recorded anymore, but we have a recording of what it was. So it's important when filling in a trace table that you don't worry too much about in which particular row you put a value, although it's usual to work across, but it is important that for any particular column the correct values are indicated and that you don't forget any of the values and then you don't cross out any of the values. Okay, so let's start working our way through this algorithm. To help us do so, I'm going to remove most of the values in the table so we can see how it works, and we'll write them in ourselves. Sometimes, and often in exams when you're having a trace table, some of the first few values are already put in, so we'll leave a few values in here. And the value of n is one that is read in from the user of the program, and in this case it's going to be 10, so I'm leaving that in as well. So let's look at the first line. So we're going to set the variable sum to 0. Notice that all the variables are here, so we just find sum, and that's set to 0. So that's already been recorded. We're going to set v1 and v2 to 1. v1 and v2 have been set to 1. And then we're going to output v1 and output v2. And so we output v1 and we output v2, each of which is 1. Then we read in the value of n. The value of n is 10. There's no way of knowing this, but the trace table has told us that it is 10. In another situation, we might have been told that the value that's read in is 10, and we would record it in the trace table. But in this case, the trace table already has that value. All the other values we'll get by going through the pseudocode. So the next line. The next line is a for loop. It starts on this line here, beginning with 4, and ends here. And all the statements in between these statements here are repeated. They're repeated more than once. So this is a loop. And the structure of a for loop is that we have a loop variable I in this case, which takes on a value, 3 in this case, and then that value is increased by 1, until it reaches the value of n. So in this case, I starts at 3, so let's record that in our trace table. And then it will, at some point, when it reaches the end of these statements here and gets to the end of the for loop, it will then go to 4, to 5, to 6, and whatever n is 10 in this case, so we'll go all the way to n being 10. So we could fill this in already and write 3, 4, 5, 6, 7, 8, 9, 10. But let's just look at where we are at the moment, which is the first value of I is 3. We're going to work our way through these statements, and when we reach the end, we're going to go back to the for loop and then put in the next value, which is a 4. But as I said, I is currently 3. So we put the 3 in. Now we're on this line here. So this is what's called an assignment. Like with an assignment, the values on the right-hand side are calculated, and whatever the result of that calculation is put into the variable given by the left-hand side of the assignment statement, with an equal sometimes being used in some languages such as Java, colon equals in others, but in pseudocode other than equals, you can sometimes use an arrow which indicates the values on the right are calculated and the result is put into the left hand side. So in this case, V1 is 1, V2 is 1, we add them together, 2, and the result of that is put into some variable which is there, so we put 2 there. Because I is 3 on this row, I'm going to work along this row with my variables. It's not critical I do that, but it's usual, it's conventional. Now V2 is calculatable. It's just V2, which is just 1, and it's put into V1. So that basically means we copied this value 1, which is in V2, and we put it into V1. Now if a variable doesn't change value, we don't have to write it again. We could just leave that particular column blank. That indicates that it has the value that it had before. So we could have left this blank, but I'm filling it in just to indicate that we have copied the value 1 from V2 into V1. And then V2, in this line here, takes the value that's in sum. So we look to the sum column, look down to the most recent value, which is 2, not the 0, notice, and we copy that into V2. So V2 becomes 2. And then we output sum. Sum, we look at the most recent value, which is 2, and we output 2. Now we fill this row in, so we naturally want to proceed on to the next row. Not that that's particularly necessary. You might have moved to the next row already or later, but in this case we filled the whole row, so we really pretty much have to. And that's quite a convenient thing in this case because we reach the end of the for loop. So it's quite nice when we have for loops to start a new row at the beginning of each iteration or each new value of the loop variable, and then trace that iteration on a particular row. As I said, it's not necessary, but it's conventional. So when we reach the end of the first iteration, the for loop, we go back to the beginning, and now I, having been 3, is now, as I said before, incremented to the next value, which is 4. So we put that in, and we work our way through these statements now with I being 4. So V1 and V2, we read the most recent values of them, which are now 1 and 2, not 1 and 1. We always look down to the column when you're reading from a variable and look at the most recent value. So 1 and 2, we add them together, that's 3, and we write that into sum. So now sum has a value of 3. The 2 has now been forgotten. V2 is copied into V1. So now the 2 that's in V2, the most recent value, is copied into V1. And the value of sum is copied into V2. So this value of sum, the most recent value, is assigned to V2, so that's 3. And we output the sum, which is 3. And that's the end of the second iteration, and we carry on. So now I is 1 bigger than the previous value, which is 4, so that's now 5. We sum V1 and V2, 2 and 3, and put that into sum, which gives us 5. We copy V2 into V1, so we copy the 3 into V1, gives us a 3 there, and we write down, or copy the sum into V2, which is 5, and output the sum, which is 5. And we keep on going. So the next line, I will be 6. Sum will be the sum of V1 and V2, which will be 8. V1 will take on the value of V2, so that is 5. V2 takes on the value in sum, so that is 8. And we output the value that is in sum, which is 8. And so we have 6. And notice that I in this case is not being used. It is in some particular loops, but not this one. 7, 8, and 9. And we're just going to do the same thing each time. So in this line, we're adding V1 and V2. So 5 and 8 is 13. We're copying V2 into V1, so it gives us the 8 there. The sum here, 13. Output the sum, 13. And we can carry on going. So now again, sum V1 and V2. 8 and 13 is 21. Copy V2 into V1, 13 there. I'll write the sum into V2, so it's 21, and output the sum, 21. Again, we sum on this line, V1 and V2, so that is 34. And we copy V2 into V1, 21, and copy the sum into V2, so it's 34, and output the sum. And last line, we sum up 21 and 34, so it's 55. and we copy v2 to v1, which is again 54, and we will put the sum into v2, which is 55, and we output the sum 55. For those of you interested in sequences, this actually gives us the Fibonacci sequence, which is always created by adding the previous two values. So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, 8 plus 5 is 13, 30 plus 8 is 21, 21 plus 13 is 34, 34 plus 21 is 54, and so on. And we can see, now looking at the pseudocode, that actually that method of creating the Fibonacci sequence is reflected in what's happening here, and that the iteration happening here is merely creating the next value. So the first two values of the Fibonacci sequence are 1 and 1, and so I is linked to the third value is 2, the fourth value is 3, and so for an input of 10, we're going to output the first 10 Fibonacci sequence numbers. Clearly, if we change that 10 to a 20, it would go on to print out or output the first 20 Fibonacci numbers. And so the trace tells us what's happening line by line, but once you look at the trace and you look at the pseudocode, having gone through the trace, you will probably have some idea about what the algorithm does generally for different things. Hope that was of help to you. Do work through the rest of the summer task. This trace will be of help to you when you come to the exercises. So you may well want to go through it yourself, possibly replay this recording, but certainly with a trace you will want to start with blank paper and work through line by line, maybe with this example first, in order to solve any traces. So good luck with that.